this is an interesting question actually. We have to integrate x cosine 5x. And what we do is we do integration by parts following this formula. Now it looks complicated, but once you get into it, it'll be simpler. The key is assigning your u. You want to assign a u to something that's going to be derived into something more simple. I wouldn't choose this as my u, because if I chose this as my u, then my du would be negative 5 sine 5x, right? And then that's complicated because then the dv would be this. This would turn to a v of half x squared, and we don't like that. So you'll see when it happens. So we're going to assign u to be x and du to be 1. And then we're going to say dv equals cosine 5x. And then v, well, we may assume this is u, then cosine u, the integral is sine 5x. But then if we had u is equal to 5x, then du would be equal to 5, and then du, and then you'd say 1 over 5, right? So when we actually use this in, we're going to say this. We're going to say, well, that equals, we're going to say u, v, so that's x and this, minus v and du. In that case, it's this and this. Now notice the 1 with this simplifies things. So we only use this. We bring out the 1 over 5, and then we say the integral of sine 5x. Well, now see, this is a lot more easy to integrate than this whole thing was. And that's the idea. Because of that 1 that's in here, we don't represent it, but it's made things so much easier. So now we just rewrite it, x sine 5x minus 1 over 5. And then in brackets we find the integral of sine x, which is going to be negative 1 over 5 cosine 5x. And then of course we expand it and we'll say 1 over 5 x sine 5x minus, well in this case that comes there and makes it a plus. 1 over 5 is 1 over 25. And then cosine 5x plus c.